All right, let's go on to our next step in our normal model information. So we know how the normal model basically works. That was our first lesson. Then yesterday we did percentages and percentiles. So finding those areas. Well, now we need to, we'll be given those percentages or percentiles. And from that, so we're going to kind of go backwards. So if we're given a percent, then we're going to get that z-score from it, and then ultimately find the context values for those sections. So let's take a look at what that means. So first of all, we'll come back to this. Let me, instead of just throwing this calculator information to you, let's kind of look at a problem first, and then we'll come to our calculator information. So first, find the z-score for the lowest 10% of data. When you have a normal model, or the calculator will find a z-score, it'll go backwards for that lower percent. So essentially, if I was to draw a picture of what's happening here, we're saying this. I thought I could do that and then write on here. I guess not. So if we've got a normal model, oh, it's drawing in white. That's why. Okay. If we've got ourselves a normal model, then, and I want to do the lowest 10%, okay? So that means this 10% is below here. The question is, what is that z-score right there? Okay. And ultimately, we're going to end up saying, what is the context value at that point? Okay, that'll be a step further shortly. We'll learn that today. But anyway, so the calculator will only calculate areas below a certain point. So when we're going to go into our calculator and do this thing, instead of doing norm CDF gives us this percent. Well, inverse norm is the backwards of that. That is, you tell me a percent and I'll tell you a z-score. Inverse norm. You tell me a percent and I'll give you a z-score. So we go to second in our calculator, second and then vars. And then number 3 is that inverse norm. Okay, and so then your screen comes up like this. When you put that area, this isn't the area below a certain point. So since this is the lowest 10%, our area below is 0.10. Inverse norm of the area below, inverse norm of the area below, inverse norm of the area below is the z at that spot. Okay. Now again, same thing as before, leave these as 0 and 1. When you put the area in right here, put it as a decimal. So we would do inverse norm of 0.10, and that tells us negative 1.28. So this location is 1.28 standard deviations below the mean. That's what that's telling me. Okay, so look here. Find the z-score for the highest 5% of data. So if we were looking at this one, this would be the highest 5%. So I've got the highest 5% of data up here, and I want to know the z-score at that spot. Well, our calculator is not going to do the highest 5%. Our calculator will do inverse norm of the area below, inverse norm of the area below, inverse norm of the area below is the z at that spot. So if this 5% is the top part, then our lower part is that inverse norm of 0.95, and that is a z-score of 1.64. All right, now look at here. This one is about a middle section. So here we have the normal model, and it's asking for the middle 50% of data. So if we have this and we want the middle 50%, so 50%'s in here, okay? So then that means we're going to give 2 answers. One answer for the left side, a z-score for the left side, and then a z-score for the right side, okay? So we need to know how much area is below each of those locations. So let's do it. If I have 50% in the middle, then I know there's 25% on each of these outside edges. So I've got 25% down here. So I've got 25%. 25% down here below this z-score that had 50 in the middle. So I'm going to inverse norm 0.25. Now, what is below this right-hand side z-score? Below this right-hand side z-score is the 25 plus the 50. So I'm going to inverse norm 0.75 to get this right-hand side z-score. Well, look at what happens. Examine these numbers. The left-hand z-score is negative 0.67. The right-hand z-score is positive 0.67. That is because of symmetry. So what I always remember to do, if I have a middle section, okay, then I usually, I figure out, I kind of visualize what's in the middle so I can see what is left on the outside edges. And once I take inverse norm of this left-hand side value, I know because of symmetry that the top one's going to be the same thing except for positive. Okay, so technically you only have to compute this one. You just know it's the negative version to the positive one. All right. So if you stop the video right now and try numbers 4, 5, and 6, we'll see how you do. All right, so here we go. Let's see how you did. Number 4, the lowest 15%, so that's what we would put in here. Inverse norm of 0.15. The highest 8%, so we're going to do inverse norm of 0.92. Here was the middle 20%. So you can visualize, here's what's happening. Look, 20% is in the middle. So if 20%, that's 80% then split between the outsides. So 40% is in each one of those outsides. All right, so I'm going to inverse norm 0.40, and then I'm going to know that the other side is the positive version of that. And we'll get here to this song in a minute. We'll come back to that. So let's take a look at the next page. All right, this is now going to the next level. They'll tell me a percent. And so then I say, oh, okay, I got to get the z-score for that percent. And then I can go find the other missing item. So they'll tell me a percent. I'll find the z-score from that. And then I should have 3 out of these 4 things given to me. And it kind of just depends on the problem, which ones they give you. So we're going to kind of have to work through figuring out which ones they give you, because they will give you 3 out of the 4, and then you can solve algebraically for the 4th. Let's take a look at an example here. Okay, in fact, I think I'm going to pull up the one that doesn't have the answers shown so we can kind of work through it together. So let me get that out here real quick. All right, so when we take a look here, we have got the Beanstalk Club. And we want to talk about various heights of the Beanstalk Club. So let's see here. Parker County chapter will take women who are taller than 1.75 standard deviations above the mean. Okay, so that's giving us some information. Plus, we knew that the average height of all women is this. So there's the mean and there's the standard deviation. Okay, so those are going to be used for parts A, B, and C. So what I always do is over here, I put 4 things that I need. So I always will put the mean, that's a mu. It's supposed to be kind of a cursive U. The standard deviation, there's your sigma. The x value is the context value, and then the z-score. Okay? So these are always, put those to the side. Those are the 4 things I need. So let's see how we can get them. Here we go. So so we know the mean and the standard deviation. Okay, so we know this is our 63.6, and we know that this is our 2.5. Okay, so now let's see what they give us. How tall do you have to be to join the Parker County Beanstalk Club? You have to be taller than 1.75 standard deviations above the mean. Well, what information is that giving me? Is that a context value height or is that a z-score? Well, if you know the definition of z-score, that's the number of standard deviations above or below the mean. This is above, so that means this 1.75 is a positive 1.75. So I've got 1.75 here. So I have 3 out of those 4 things, and now I'm going to solve. So I'm going to set up my z equals x minus the mean. So here's my z equals, okay, my x, that's what I don't know, minus the mean, which is my 63.6, over the standard deviation of 2.5. Okay? And so now I'm going to do algebra and solve. So I hope you know you will multiply both sides by 2.5. So I'm going to multiply by 2.5 and then add that 63.6 over. You end up getting something that looks like this. So there we have it. See, our x was unknown. Here was our setup. Multiplied by 2.5, that gave me this. Then I added that 63.6 over. So you have to be 67.68 inches tall to be in the Parker County Beanstalk Club. All right, the next one gives us a little bit different information. Here we have this. To be in the Tarrant County Beanstalk Club, they will only take the top 8% of women. All right, so let's talk about what we have and figure out how we can find the part we don't. So we know our mean was 63.6. We know our standard deviation was 2.5. I don't remember. 2.5. Okay, cool. So our standard deviation, 2.5. All right. Now, are they telling me an X value? No, they want to know how tall do you have to be? That's the context value. How tall do you have to be? That's the height. That's X. Okay. So what is missing is this z-score, okay? But if I have a percent, then that's telling me a location, and I can get the z-score then. So remember this, if I have the top 8%, here's my top 8%, I can find the z-score at this placement because I can do inverse norm of the area below is the z at that spot. So this is the area below, 0.92. Now, here is the tricky thing. Oh my gosh, this is major, common mistake. People want to put that the z-score is 0.92, and that is not true. I almost kind of halfway like it when you do it because then I get to sing my song, my rant at you. And the song is this one. Goes to the champion. Percent is not the Z. It's not the Z. You use percent to get the Z. Use area below as the percent. Percent is not the Z. So see over here? This percent, 0.92, it's not the Z. It's not the Z. You use percent to get the Z. Use area below as the percent. So I'm going to do inverse norm of the area below. So I'm going to second distribution. So second vars, number 3, inverse norm. Percent is not the Z. Okay, and I have the video of it, which I'm not going to play with for you right now. You had to hear it in person. So there's my inverse norm of the area below is 1.41. That's my z-score, not 0.92. All right, super common mistake. So much so I got mad at everybody doing it. So I wrote a song, very powerful song. Percent is not the Z. Okay, so there is our z-score, 1.41. Now I'm going to set up my equation. I have 3 out of the 4 things, and now I'm going to solve. So I got my z equals x, I don't know, minus the mean over the standard deviation. X minus the mean over the standard deviation. And so then I'm going to go and put that in there. And let's see what that looks like here. Pull this on down so I can see the work. There we go. So, see, there's our z-score. See how I wrote that here? To get the z-score, you do inverse norm of the 0.92 is the z at that spot. Then I plugged it in and solved for x. You have to be 67.13, so they're not quite as picky in Tarrant County. Well, let's see about Dallas County. Oh, they will take women in the 88th percentile. So, what do we know? Okay, we know the mean is 63.6 and the standard deviation is 2.5. We don't know the height. And if you are in the 80th percentile, remember percentile was area below. So that is the area below, but that's not the z-score. Percent is not the z. It's not the z. You use percent to get the z. So I'm going to go inverse norm of 0.88 is the z at that spot. That's 1.17. And then I do the math from there. So you have to be 66.53 inches tall in order to be in the Dallas County. So they're not as picky even as Tarrant or Parker County. All right. I would think it might have been the other way around. So there is that. So here we go. Let's try this. So I've kind of laid out, there's some basic stuff there. Let's now see how we can do. Let's start now mixing together the last several days of work. Here we go. All right. We have got a pizza parlor franchise. And they say that the average amount of cheese should be 8 ounces and the standard deviation of 0.5. So I'm already kind of starting off to the side, making my information over here. Okay, I know the mean is going to be 8 and the standard deviation is going to be 0.5. Okay, all right. So now let's go to the question. An inspector picks out a large pizza at random in one of the pizza parlors and finds that it is made with 6.9 ounces of cheese. So that's a context amount. So if that's a context amount, then that's going to be your X. Okay? So a context amount is your X. So I know I got 6.9. If the pizza parlor is really putting 8 ounces of cheese on the pizza, what is the probability? What's the probability? That sounds like what we did yesterday when we had to norm CDF to find the percent or the area. Okay, so if you need to find probability or proportion of observations or percentage, that's when we use our norm CDF. Okay, so we're going to find the probability that it is 6.9 ounces or less. So here's what's going on. And you can draw these out to kind of like visualize what this is saying. We got 8, they find a pizza at 6.9, and they want to know, hey, what proportion of pizzas are below 6.9? What was the likelihood of that? Was that unusual for me to find one that little cheese on it, or is that just sampling variability? Well, remember from the lesson yesterday, you had to get that z-score, so you got to do your little x minus the mean over the standard deviation, x minus the mean over the standard deviation, and that ends up being negative 2.2. Okay, so here we have this problem. So I did my x minus the mean over standard deviation. I got negative 2.2. So then, remember, you were trying to find that area below that 6.9. So this is 2.2 standard deviations below. So that's kind of an outlier. So that makes me think, whoa, that's concerning. Okay. Yeah. Wait. I wonder if I did that right. I'm thinking there might be a 0 in there. I wrote that wrong. So it's 0.0139 Because if I'm an outlier, if this pizza is an outlier, see, I should use common sense. 13.9% doesn't seem right. That doesn't seem like outlier. Unusual is less than 2.5%. So if I did that, it was really 1.39% of pizzas have 6.9 ounces or less. So that tells me the inspector knows, okay, either I've got a really rare pizza or the inspector says, I'm not so sure that your average is really at 8. So you might be chinsing out the customers and not putting 8 ounces of cheese on those pizzas. All right, so let's move on to the next one. Next question says this. If the amount of cheese on the pizza is 3 standard deviations below the mean, what tells me the number of standard deviations away from the mean? Z-score. So this is telling me the Z-score, 3 standard deviations below. So that's telling me right now at this point that Z equals -3. All right, so what's the minimum amount of cheese that needs to be placed? So that's saying, hey, what is X? I don't know. What's that context value? How many ounces are at this location of -3 standard deviations down? Okay, so here's what I'm going to do. I'm going to come on over here. I'm going to get myself one of these things here, and let's do this. Okay, so I'm going to move this thing around. And so I've got the mean is 8. The standard deviation is 0.5. Unknown is how many ounces of cheese. Okay, and then remember it told me that the 3 standard deviations below the mean. So that's why I know that my Z-score is -3. So I'm going to set up my Z equals X minus the mean over the standard deviation. And then I'm going to do algebra to solve. And I get 6.5. So this tells me that if the inspector found a pizza that only had 6.5 ounces of cheese on it, then that pizza parlor would be in danger of losing its franchise because they're chinsing out the customers and not holding it up to standards. Okay? All right. What is last? What amount of cheese do the bottom 5% of pizzas have on them? Okay. So what is this if they tell you a percent, you give me a percent, I'll tell you a Z-score. Percent gives me a Z-score. Percent is not the Z-score, but you will use it to get the Z-score. Percent is not the Z. It's not the Z. Use the percent to get the Z. Use area below as the percent. Okay, so do you see what's happening here? So here's what I have. The mean is 8, standard deviation 0.5. I don't know the amount of cheese. So I do not know the amount of cheese that's in the bottom 5%. Okay. But it is the bottom 5%, so inverse norm of the area below is the Z at that spot. So that's -1.64. So then I'm going to set up my equation. Here I have Z, -1.64 equals X minus the mean over the standard deviation, and then I solve for 7.18. So the bottom 5% of pizzas have 7.18 ounces or less on them. All right, and what about the top 5% of pizzas? Well, okay, let's now start using our brain here. Symmetry. We just did the bottom 5%. Okay, you see this? We just did the bottom 5%. So what is the Z-score going to be for the top 5%? Well, the top Z-score for the top 5% is the positive version, okay? So we've got to get to that point where we can start using some of our common sense to work for us in these cases. So the top 5% is going to be a Z-score of positive 1.64. All right, so now we set it up. Z equals X minus the mean over the standard deviation and solve. So the top 5% of pizzas will will have 8.82 ounces of cheese on them. Whew. Okay, lots. We're going ins and outs, given lots of different informations. So it takes a while to get used to these. So these are so important to practice. Oh, look, what do you notice about those z-scores for the bottom 5% and the top 5%? One's positive and one's negative. All right, so now let's start seeing if you can do some of these yourself. And then we'll check. So we're going to do some pause and then get the answer. So here we go. So mobile homes are very tightly constructed for energy conservation, but they're worried about this buildup in pollutants generated indoors. Okay. So they did a paper on the survey of the nitrogen dioxide levels inside mobile homes, NO2. So they discussed the various aspects of the NO2 concentration. In one sample, in homes near Los Angeles area, the average NO2 concentration for kitchens during the summer was 36.92 and the standard deviation was 11.32. Okay, so to me, that tells me that's what I'm going to be putting here for my mean and standard deviation over there. All right, so the first question says, what percentage of homes have NO2 concentrations above the toxic level of 57.3 parts per billion? So that 53 parts per billion is going to be your X value. There's your hint. Okay, so I'm going to pause. You pause. Pause the video and work this problem, and then let's see how you do. Time's up. You worked the problem. Let's go back to hit this and see how you did. Okay, so that I want above this value here. So I get my X value is the context of 57.3. So next, I can see I have these three things. So with those three things, I can find my z-score. So there's my z-score, X minus the mean over the standard deviation. So my z-score is 1.8. All right, so 1.8 standard deviations above the mean. So what I need to do now is get the area. If you're finding probability, the three P's, probability, percent, proportion of observations. If you're going to do those three P's, use norm CDF. So I'm going to norm CDF, and I want to go above, so I'm going to go from 1.8 to 99, and I get, was it 0.0359 or 0.359? Okay, so one of those, look at there, I'm inconsistent on what I'm saying there. So is it from 1.8 to 99 is, oh yeah, 0.0359. So see, there's supposed to be a little zero in there. So it is 3.59% of homes. So I need to have a little zero in there in between the decimal and the 3. Okay, moving on. Next question. What proportion of mobile homes in Los Angeles have the highest 10% of toxicity levels? Okay, so that's weird that it says that. It should, I guess, say what is the toxicity level? Yeah, what is the toxicity level at the highest 10% that the highest 10% of mobile homes have? Okay. Well, anyway, so what I say to myself is I've got this percent. So if I'm thinking of the normal model, I've got this highest 10%. So I'm going to use that percent to get the z-score. Now that percent is not the z. It's not the z. Use the percent to get the z. Use area below as the percent. So since that's highest 10%, I'm going to use the area below. Inverse norm of the area below is the z at that spot. Okay, pause and work this problem out. All right, you have Worked this problem out? Here we go. So there's the mean and the standard deviation. We are wanting to know the X value. We are wanting to know how toxic are the top 10% of toxicity levels. Okay. So to get my z-score, I inverse normed the area below. I inverse normed the 90% below is 1.28. So now I have z. Now I have mean. Now I have standard deviation. And look how I set that up. Z equals x minus the mean over the standard deviation. Use algebra to solve for x, the context value, the toxicity level. The top 10% of homes in Los Angeles have 51.41 parts per billion NO2 concentrations or higher. I should have put that in the parts per billion. Okay. Ooh, look at here. Middle 40%. So you're going to have two numbers resulting from this. Okay. Because remember, if we say like middle 40%, you're going to have a lower bound and an upper bound with that 40% in the middle. Okay, so find your z-score on the left. Then you know the z-score on the right is symmetrically positive. Okay, and so then you're going to have to do two equations. You're going to have to find, so once you get a z on the left and a z on the right, solve for an x on the left and an x on the right. Okay, pause and do that. All right, so here we go. Look at what I wrote over here on the left, the mean, the standard deviation. There are two unknown x values. There are two z-scores. The lower one was that inverse norm, because if 40% is in the middle, that leaves 60% mixed or between the outside edges. Okay, so I've got between the left and the right, I've got 60%. So 30% in one of those sides. Okay, so that's why I inverse normed 0.30. Okay, because I got 30% down here and 30% up here. All right, and then my z for my upper score is positive 0.52. There's my two z-scores. Now, set up two sets of equations. So look here. Here is the math for the lower x value. I set it up with a negative 0.52 z-score. Okay, and here is the math, the algebra for the upper z-score. I set it up with the 0.52 upper value. So our middle 40% of homes have NO2 concentrations between the 31.03 parts per billion and the 42.81 parts per billion. All right, that's the end of that one. Let's move on. More practice. I think these ones kind of, go ahead and pause. This page, you should start kind of be getting now that you're hopefully starting to get the hang of. So pause. Try these next four. They're pretty basic. Try those, and then I'll reveal them in a second. Okay, pause and work. All right, let's see how you do. 11A, the highest 20%. Well, pooh, I did that wrong. The highest 20%, look at what I did, and it's wrong. The highest 20% has 80% below it. So I should be doing inverse norm of 0.80, and that gives me a positive z-score of 0.84. Okay, there you go. B, the highest 75%. So 75% is up top, means 25% is below. So that's inverse norm of the area below. Is the z negative 0.67? Lowest 3%, so that's way down here, negative 1.88. And then look, middle 90%. So see with this middle, if 90% is in the middle, then you have 5% on each side. So I'm going to do inverse norm of 0.05, and then that's negative 1.64. And I'm going to know from symmetry that this one's the same on the right, but it's just positive. Okay. Next, number 12. Oh, looky here what we got. Okay. So what I want you to do is 12 ABC and pause, do a little self-check, and see how you do on these. You're getting to that point. Remember what this means. The normal model, these Angus steer are weighted according to the normal model with a mean of 1152 and a standard deviation of 84. Okay, try those next ones. Pause so you can practice. All right, let's check. Over 1250 pounds, that's an X value. So I did X minus the mean over the standard deviation, got a Z score, and I'm wanting to know the percent. So remember, when you find percent, probability, proportion of observations, you're going to use norm CDF. I even do have a song for that. It says, find probability when you find proportion of observations. When you find percentage, the 3 P's, use norm CDF. All right. So we went above it, and that ended up being 1.17 to 99. Next, under 1200. So get the z-score at 1200, and then go from negative infinity to that z-score. Next, between two values. So this is a pure review of yesterday's stuff. So we got the two x values, and then we norm CDF'd between those two z-scores. All right, next thing, but now we are solving for the x values. Okay, so pause, do number 13, parts A, B, and C, and let's see how you do. All right, let's check it out. Here we go. Inverse norm the area below is the z at that spot. So highest 10% has 90% lower. That's inverse norm of 0.19. That's 1.28 is your z-score. X minus the mean over the standard deviation, and we solve. So the heaviest 10% of steer weigh 1259.52 pounds or more. Lowest 20%. So inverse norm that 0.20 to get the z at that spot. And then here we set it up to solve for X. The leanest, 20% of Angus weighed 1081.44. Oh, middle. So we're going to have to find two values. We're going to have one on the left and one on the right. So if 40% is in the middle, then that's putting 30% on either side. So I'm going to inverse norm the 0.30 is negative 0.52. And I know because of symmetry, the top z-score is positive 0.52. So there we go. I'm going to set up both equations, one with the negative 0.52 and one with the positive 0.52. Solve, and I get those two values, 1108, 0.32, and 1195. All right. So let's take a look at this one. Okay, because we're starting to just practice these a whole lot. But let me just show you a little bit how this looks different. Here, okay, you can see clearly they're lining out the things for you. The mean is 1250, okay? Cha-ching, got that. But look, we don't know the standard deviation, okay? That's what we're going to be finding. But let's look at this middle statement. 35% of data is below 1200. Well, 1200 is another context. That is your X. So that 1200 is your X, and you're going to use this 35% below. That's percent. You're going to use percent. That percent is not the Z. It's not the Z, but you're going to use percent to get the Z. Use area below as the percent. Percent is not the Z. So your Z is inverse norm of the 0.35 is the Z at that spot. And it looks like that Z is negative 0.39. So then see, look here what I have. So there's my z-score, my X minus the mean, and this standard deviation I don't know. And then, okay, I'm going to multiply by the standard deviation. Okay, get that variable off the bottom. So I'm going to multiply the left by the variable standard deviation. So look, I have negative 0.39 SD equals, and then I did 1200 minus 1250 is negative 50. Then you're going to divide by the negative 0.39. So make sure you can do that algebra. I think this one's the same. So practice this one. Mean is 0.64. Oh, but this says 12% of data is above this X value. 12% above. What does that mean? 12% above means 88% below. So I'm going to inverse norm 88% below is the Z at that spot. And there it is. Okay, so you can work those out. Next, you don't know the mean. You have the standard deviation, but you don't know the mean. You have the X is 10, 90% above it. Okay, 90% above it. So that's telling me this. 90% is up here. So I need to find the z-score with 10% below it. So inverse norm of 0.10 is negative 1.28. Solve for mean. And the last one is similar, but it's got 3% below, so you're going to inverse norm your 0.03. All right, holy moly, that is a lot. And it's just mixing it up all together. So hopefully we've done enough practice that you feel like you can come on over here and start working on the assignment, okay? And so, I would just like to encourage you to always write down I just always work through this. Write down what your mean, your standard deviation, your X, and your Z score, okay? And the thing is that there are several different ways you could get a Z score, depending on the information they give you. You may have to do it with the formula, X minus the mean over the standard deviation, or you may have to do it with your inverse norm of the area below is the Z at that spot. So if they give you a percent, you can get the Z-score from that. If they've given you these other three items, then you can get the Z-score from that. All right, lots of information. You just have to go at it and practice it and process it. Okay, so go for it. Hope that you can come out on the positive side of that. Good luck to you.